Hello and welcome back to Paleocast. My name is Dave Marshall and this is episode 91, Dinosaurs of Appalachia, in which we're joined by Chase Brownstein, Research Associate at the Stamford Museum and Nature Center, Connecticut. This episode was another listener request, and so it goes to show that we do listen to those and we do try and arrange interviews wherever we can. So please keep those coming in, along with any other feedback that you might have. What do you love? What do you hate? Let us know. We're currently preparing for the next Paleocast art competition, so if you have any paleo merchandise that you could donate as prizes, please do speak up. This year, we'll be running the competition a little later to allow us some time, firstly, to source some really awesome awards, and secondly, because I'll be away on a huge field trip for most of the summer, which I'm planning on discussing the details of in an episode very soon. As with every podcast we release, we've got pictures on our website, and we'd be appreciative if you could share it on social media, and any 5-star ratings would also be greatly received. Please make sure that you're also signed up to our Facebook, Twitter, and YouTube channels so you don't miss any of our future content. As for this episode, there's some quite surprising content and some very positive messages, so please stick around until the end, and we hope you enjoy it. Hi Chase, thanks so much for coming on the show.
Oh, thanks for having me.
So, can you give me and the audience an impression of who you are and how you became a paleontologist?
Oh, sure. Well, I'm a researcher. Located in Stamford, Connecticut, and I'm a research associate at the Stamford Museum and Nature Center. And actually, there's a kind of a funny story of how I got that position, which is my first position at a museum. I was actually hiking in their grounds. They have a nice couple acres of forest, and I bumped into the director of the museum, and I had asked her, I said, in all the years I've visited you guys, I've never seen a exhibit on fossils. And she said, well, how about that? James Gurney is doing an exhibit coming this spring in our halls, and we're actually looking for somebody to organize the fossil collections and help out with the exhibit design. So it ended up being rather serendipitous, and I ended up first becoming an intern there, and then I assumed my current role as research associate.
Have you always had this fascination with dinosaurs and a will to see paleontological content in museums and stuff like that?
Oh, yes, definitely. One of the things I was sort of very intrigued by, when I was very young was, what the past below my feet was, and what the eastern United States was like, because in all the fossil books, the paleontology books you buy as a kid, you hear about these fantastic expeditions out to the western United States, out to Mongolia, out to Africa, into the deepest parts of these grand sedimentary layers. And for me, that was fantastic, but I didn't know what was going on around here, 65 million years ago. So I always had that fascination, and I don't know what caused it, but here I am now, and I'm, continuing to question what occurred in that distant past around in Eastern North America. So it's always been a bit of an interest of mine.
So we'll get into details of your local area in a bit, but first, what's an average day like for you in the museum? What kinds of things are you doing?
Well, my job is primarily research. So I will head out to other museums to study their fossils. I'll, identify fossils in our collections. I'm there whenever the curator needs me, so I have helped with curation, exhibition, any sort of thing that involves fossils, I'm the hand for that. The tasks range from uploading manuscript files to systems on journal websites to identifying that horse tooth to planning the next exhibit if it involves fossils and geology.
Right, well, this interview is going to be all about the Appalachian Mountains and the fossils, the dinosaurs that we can find there. So, can you tell us about the Appalachians today? Where are they? What are they like?
They're located in eastern North America. They run from the tip of the northeastern United States in Maine all the way down to this southeastern tip in Georgia and even in Alabama. Those mountains are very, very old mountains. They were formed during the Paleozoic. They're marine sediments up there predominantly, and they're actually composed of several different chunks that were formed during different times. But everything up there is very, very old, and because of that, they're actually somewhat low mountains compared to the Rocky Mountains. So they're not as high, but I guess their age, at least for the geologist, makes up for that.
So we've got lots of different ages all mixed together in the Appalachians. What proportion of the rocks there would be the right age for finding dinosaurs?
It turns out that actually none of the actual sediments in the Appalachian Mountains are of the right age for producing dinosaurs. If they were there, they were eroded away. In fact, the places where we get Appalachian dinosaurs from this area are actually in the coastal regions that are right outside the Appalachian Mountains. And this is because as sediment was carried down by rivers from the Appalachians during the time of the dinosaurs, it deposited in these coastal areas, and that's actually where we get dinosaur bones because of the fact that that's the only place where we have the sediment from that time. So we're looking at a very limited record that's mostly marine during the Cretaceous, which is the time period I study.
So that would all be allochthonous then, meaning that the fossils aren't found preserved in the environment in which they lived. They've been transported to where you find them.
Yes, yeah, that's predominantly the case. Although, in some sites like the Chronister site in Missouri or in Ellisdale, we think that some of the vertebrate remains that we assume to be either near shore terrestrial or amphibious actually did come from not too far away from where the deposit was located back in the day, so to speak. But yes, primarily we have a fossil record that's not with organisms preserved in their original environments.
And are they generally really poorly preserved then? If they're being transported, a big dinosaur is going to fall to bits over long distances. Do you get isolated leg bones, or do you find quite a lot of articulated specimens?
Unfortunately, though we don't find a lot of articulated specimens, I would say that the fossil record from the Cretaceous period in eastern North America is a lot more well-known than people might think. So we get a lot of isolated fossils or, one or two fossils associated together. But if you look, take a step back and you look at all of them together, we actually have a pretty good understanding of what was going on in the eastern United States and Canada back then. In fact, compared to fossil records in Europe and Australia in particular, it's not that far away. It really isn't as bad as people think. And I think partially, it has to do with what we're comparing it to, the treasure trove that is Western North America. But we do know a lot, actually, about Appalachian dinosaurs and other, terrestrial vertebrates from the time I studied the Cretaceous.
How much rock would you have to shift through to be able to find a dinosaur on the East Coast?
Well, you see, it varies. A lot of the sites around here are, we take out sieves because of the fact that, a lot of the fossils are actually just, floating around in riverbanks. They've been eroded from the Cretaceous, sediments lining the banks. So a lot of it is actually, the fossils are right there. You just have to have a good eye and a good sieve with the capability to trap microfossils, and you've got yourself a pretty good fossil record from Eastern North America. So that's really what we get up where I am. But farther down in places like Alabama, you do have to excavate a bit because you have chalk, and that chalk is where the dinosaurs are going to be preserved. So some excavation is required down there for that type of thing. But up here, mostly it's just collecting from, stream gravels.
And do you get to go out in the field much?
Yes. I've gotten to go out into the field several times around here, though, we don't usually find much, unfortunately. A lot of shark teeth, a lot of shells, and they're very pretty fossils. But finding the terrestrial fossil is hard.
And where would you say the best place out of all of the Appalachians would be?
That's an excellent question. I don't know. I would say that it depends on what you're looking for. If you're looking for a microfossil assemblage. Just currently, the best known one I would say is Ellisdale in New Jersey, and we have so much from there. I've been working on the dinosaurs from that site since this fall, and it's just we have a very complete record from there. But if you're looking for large complete dinosaur specimens, Alabama is a very, very promising place. There's been several discoveries down there recently. Both terrestrial and marine vertebrates. You may have heard, Eotrachodon orientalis has recently been described from deposits down there. So is Appalachiosaurus, and recently there was an abstract out there, and they have a baby nodosaur, which is a type of armored dinosaur from those chalks down there as well. So it depends on what you're looking for.
Okay, well, let's go back into the Cretaceous now. What are the Appalachians like at this time? What's the climate like? What does the land mass look like?
Sure. So this landmass that I study, Appalachia, named after the mountains, was pretty variable actually in habitat. Along the coast of Eastern North America, or Appalachia, at that time, you would have had, both these sort of, giant, versions of the Everglades, massive glades and marshes, as far as the eye could see. You'd have, coniferous trees further inland. The Appalachians would have appeared perhaps slightly, shorter than they are today, but still, you could picture a similar site as you would see perhaps in the Great Smoky Mountains of North Carolina today. Going into the western part of the landmass, rather, this was a huge expanse of what we think were plains. We don't really know because of the fact that being plains, no big rivers really running through there that could deposit sediment that would preserve the fossil record. But we think that they were these fantastic plains. So Appalachia was really sort of a wonderland of, prehistoric habitats and prehistoric animals.
And where does it sit in relation to other continents?
Yeah, Appalachia as a landmass, was formed alongside its western counterpart, Laramidia, by the flooding of the interior of North America. And so it sits right about where Eastern North America is now. It ran all the way from the tip of northeastern Canada all the way down into northern Alabama, Georgia, Mississippi, and as far west as eastern Kansas. And it was actually oriented, its eastern shores were oriented to the south compared to where eastern North America is today. So it was sort of tilted southward during that time. So it's very similar to eastern North America today in shape, but with a slight kink, if you would call it that, I suppose.
Right. Let's talk dinosaurs now, and you'll have to forgive me if I don't know any of the genera. You need to explain it to me in kind of land before time terms for me to understand. I'm a invertebrate worker.
Sure.
So, right, let's go through some of the dinosaurs known from Appalachia. Are these the kinds of things that we're already familiar with?
So I am ever more convinced that the more we look at Appalachian dinosaurs, the less we will know about dinosaur biogeography and evolution during the Cretaceous. And the reason I say this is because Appalachia harbored a dinosaur fauna that so far seems to be completely different from anywhere else on the globe during that time or during the Mesozoic. And so, just to highlight some of the crazy animals we have around here, if I can use that term, we have Tyrannosaurs, kind of like T-Rex, but instead of the puny armed fellows we know from Western North America, we actually have giant armed Tyrannosaurs. These animals had gigantic hand to humerus portions. So their lower limb bones for their arms were gigantic, topped with huge claws several inches long. We have duck-billed dinosaurs that were probably the ancestors of other duckbills that would colonize the globe during the late Cretaceous, 70 million years ago or so. We have colossal relatives of those duck-billed dinosaurs that perhaps stretched 50 feet long from nose to tail. We have armored dinosaurs called nodosaurs that were, tipped with spikes, throughout their body with armored heads and armored tails. And we even have some of the smaller dinosaurs that had relatives elsewhere. We have the raptor dinosaurs, the dromaeosaurs, with their sharp teeth and their iconic curved sickle claws on their feet. And we have the ornithomimosaurs, the ostrich mimic dinosaurs, which with their long necks and beaks and feathered coats, were probably omnivores in the Appalachian ecosystem. So we do have a surprising diversity of dinosaurs, including some forms that are not known anywhere else.
So you've got some unique dinosaurs in Appalachia, but do they belong to unique families, or are they all the same kinds of larger groups that we know?
Yeah. So, what we have on Appalachia is a unique record because of the fact that a lot of the, dinosaurs that we have around here are, sort of ancestral to those out west, or at least, more basal. They fall closer to the common ancestor of, families like the Tyrannosaurs on the tree of life. And, in fact, further, in recent discoveries, of tyrannosaurs and duck-billed dinosaurs, things like that, have actually shown that their form, even though we don't have enough evidence to name new families from Appalachia now, it's starting to show a pattern that they all fall in a similar position on the trees of life that we're studying, and that tells me that perhaps with a little more digging and a little more research, some new families may start to emerge.
Wow.
Yeah. So it's a very, very exciting time to be researching Appalachian dinosaurs. Because as many might say about work around here, because the fossil record is comparatively poor. It's not as well researched as, stuff out west. But that also means that there's room for discovery.
Have there been any particularly spectacular or unusual finds in the Appalachians?
We in Eastern North America have really a unique fauna because of the fact that, we don't have an ecosystem that's, like one anywhere else on the globe during that time. So fossil find I would highlight is actually this giant Crocodilian Deinosuchus rugosus. And this crocodilian stretched about 26 to 28 feet long from nose to tail tip. It was a generalist carnivore or predator, meaning that it basically it ate everything that was big enough to sate its appetite. We have evidence for its bites on turtles and even on dinosaur limb shafts, particularly those that could belong to Tyrannosaurs, the classically big bad meat-eating dinosaurs. And so Deinosuchus, incredibly, and this is actually from work from a guy named David Schwimmer, who's down in Georgia. He's been working extensively on these crocodilians. And what he's found is that they may have actually been very, very common in Eastern North America. Even more common in Eastern North America during the Cretaceous than Nile crocodiles are in the Nile River, and caimans are in the Amazon, is what he says in his book. And I think there's evidence for that. So we have this super common gigantic crocodilian, wandering around in Eastern North America, perhaps as a top predator. So it really goes to show that, there's something special going on around here.
Couldn't that just be preservation bias? I mean, you were talking before about how all of the dinosaurs were allochthonous. They've been washed in from the mountains into the coastal regions. But then you've got all of these crocodiles that are living in the aquatic environment. So they would be preserved more regularly than dinosaurs.
Yeah.
And similarly, the dinosaur leg that's been chewed upon by one of these crocodiles, could that have been washed into the water rather than seeing it as a direct predation?
Yeah, so that's a great question. With Deinosuchus, just in terms of the frequency of remains, just in comparison to even fish fossils, the Deinosuchus fossils aren't as common as marine fishes around here. We get a surprising lot of them, and so yes, preservation bias is most definitely a factor in the preservation of a lot of Appalachian vertebrates. But at the same time, it does seem that these crocodilians were at least, somewhat common in Eastern North America, at least more common than they are out west, probably, because we have, just a great record of their teeth and, other bones from Eastern North America. Whereas in the Western United States, finds are, somewhat more few and far between. That's still an area of ongoing research. And, I'm more so the dinosaur guy. That, I guess, the commonality of Deinosuchus remains around here is definitely something to be awed at.
Well, let's focus a little bit on the comparison of Appalachia to Laramidia. How do these two continents, separated by this seaway in otherwise North America, how do they differ to each other in terms of the dinosaur fauna?
Well, in Laramidia, we have sort of the close ancestors of, the famous clades of late Cretaceous dinosaurs. We have ancestors of Tyrannosaurus rex from Utah and elsewhere. We have the horned dinosaurs, things that, are close relatives of Triceratops. We have a whole plethora of duck-billed dinosaurs from the crested Lambeosaurines to the, crestless Saurolophines, we have that whole great fossil record out there. We even have, even more bizarre forms from Laramidia, things like the Pachycephalosaurs, which were the bone-headed dinosaurs. We have Ankylosaurids, which were the armored dinosaurs with the big, club tails. And we have, Therizinosaurs, which were these, bizarre bird-like dinosaurs with gigantic, claws on their hands and long necks and small heads. And we have these small little guys called troodontids, which were kind of like, raptor dinosaurs, except they usually had smaller sickle claws on their feet and their teeth were, a bit differently shaped. So we have a whole bunch of dinosaurs from Laramidia. If we take a look at Appalachian dinosaurs, the, fauna, though the diversity is, smaller. We do see some surprising forms. As I said, the big-handed Tyrannosaurs, the giant duck-billed dinosaurs, and, the ancestral duck-billed dinosaurs. We all have those guys around here. And so, there are those two faunas are different from each other. That's what current records indicate. And because of that, in order to understand North American dinosaur evolution, it's imperative that we look at, both land masses and their faunas.
Okay, so the big question, why were they different?
I can tell you that it probably has to do with, the classic, isolation sort of explanation, whereby, the ancestral forms isolated on Appalachia, from everywhere else in the Northern Hemisphere, they evolved, novel, features, and, became, or at least, composed an entirely distinct fauna from, those out west. So, it probably has to do with, isolation and Appalachia acting as a refuge for these animals. But, several other things could be going on. We have teeth from raptor dinosaurs in the southeastern United States that kind of resemble those from raptor dinosaurs out west. These are called the Saurornitholestes. These are small raptor dinosaurs, but their teeth are pretty distinct. And these teeth coming from Alabama and South Carolina kind of do resemble those western forms. So there is a record of perhaps some possible interchange there. But as further research goes into this, I'm somewhat confident that some surprising patterns in their dispersal and dinosaur dispersal during this time will emerge.
Before you mentioned about the abundance of crocodiles, are there any other noteworthy differences in the composition of the whole fauna of Appalachia and even Laramidia in comparison to the rest of the dinosaurs, the contemporary dinosaur faunas in the rest of the world? Are they the same as Europe or China or anything like that, or are they completely unique?
Sure. So, Laramidia and China and Mongolia and, sort of the, countries that produce a lot of interesting dinosaur finds from, Asia, those, areas share a lot of similarity in their dinosaurs. So, Asian and Laramidian faunas during the late Cretaceous are very similar. Europe was probably somewhat like Appalachia, just in terms of how different it was. Faunally, Europe and Appalachia differed somewhat, though those patterns are also starting to emerge. Europe, like Appalachia, was sort of isolated, and so we have records like that coming from Romania of dinosaurs in Europe that were, unlike any others from around the Northern Hemisphere. In the same way, though it's a different fauna, Appalachia has that different dinosaur fossil record. So, Appalachia, Europe, and Asia and Laramidia are sort of the three major regions, it seems, for the Northern Hemisphere dinosaur faunas. But as comparisons with European faunas become more clear in regards to Appalachian ones, I would say that, the Appalachian dinosaur fauna will, just emerge as something that is even more distinct, because in Europe during this time, we have possible relatives of stuff from Asia and Laramidia. Though this is debated, there is a dinosaur called Baloar from Romania that may be related to Velociraptor. And Velociraptor is a sort of, extremely derived or, quote unquote, advanced raptor dinosaur from Asia. So, there is some record of perhaps similarity between European and Asian dinosaur faunas. But right now it seems that Appalachian dinosaur faunas, European dinosaur faunas, and Asian/Laramidian dinosaur faunas were somewhat distinct from each other.
Is the same true of non-dinosaur animals in the area as well? Sort of things like pterosaurs, for example, that could travel a lot further. Are they different as well, or are they a bit more homogenized?
So, the pterosaur fossil record, for example, in Appalachia, everywhere else, pterosaurs are poorly known. On Appalachia, we really have an issue with them, because, we only have, a literal handful of fossils from east of the American interior from pterosaurs. So it's hard to make judgments about their, dispersal during this time period. But I will say that, it does seem that, at least from the amphibian and, reptile, fossil record from Appalachia now, we have several species known only from Appalachia. And just like the dinosaurs, they're, less derived than relatives out west and relatives in Asia and relatives even in Europe in some cases. So, it seems that the overarching pattern among Appalachian vertebrates is that, they were sort of relics, they're relictual clades that survived and thrived on this sort of landmass that was untethered from all others during the Cretaceous.
So, in summary, do you feel that the dinosaur fauna from Appalachia has been underappreciated by either academia or the public?
I would say that the Appalachian dinosaur fossil record, really the record of Appalachian vertebrates, I wouldn't say it's been underappreciated. It's just been obscure. One of the great things I think about paleontology as a science is it allows us to step into the past. And it allows us to look at, life. It allows us to look at the subject of biology in a way in which we get 99% of, the time of, the record of the time of life on Earth. We get to look at that, and it's I think hard to look at a record which is comparatively fragmentary. I think that's simply because, we like exploring and we like, knowledge. Knowledge is something that drives us as a species. So I think that, in terms of Appalachian dinosaurs, I think it's hard to sort of, have, interest in that. I guess, for me, it was just an interesting idea that led to it. What happened under my feet during past time, but I think it's simply just been obscure, and because of that, less interest there's been less interest in these vertebrates, and so I think it's just a matter of interest and a matter of the fossil record, sating that interest. But I would not, say that, there's been a lack of interest.
How does the museum deal with this? I mean, we've got all the dinosaurs from the Morrison Formation. You've got giant Diplodocus casts that people are wanting to see, giant T-Rexes. How do you put a tiny little bone in front of them and say, hang on, this is your dinosaur? It's just a tiny little toe bone, but it's more important and it's more spectacular.
Right. Well, I think it's going to have to be, or at least, for what I've seen, a lot of museums that are, more local in the eastern United States have done this, trend towards focusing on, stuff from around here, and have done it successfully. So, for example, the New Jersey State Museum just reopened its fossil galleries, and, they displayed Dryptosaurus. And Dryptosaurus is, that big-handed tyrannosaur. And they've displayed two of them fighting each other. And this is in a classic position, one that was painted by the great artist Charles Knight back in the early 20th century, if I remember correctly. And, they're fighting. Through, innovative research techniques and through, comparative anatomy and phylogeny, we can understand better how these dinosaurs looked. And we can present sort of a more complete image of them to the public. And, that's important because I think, one of the questions I get asked a lot as a worker in this field is, why does paleontology matter? And, there are a lot of answers to that. There's the answer, it can help prepare us for, facing the environmental challenges we now face, and can teach us a lot about life and how it evolved, can teach us about biology. But I think there's, another great reason, and that's just, paleontology just represents, I think, a sort of a grounded interest of humans in where they came from and, what happened before they were there. And, to fill that gap and to tell them, what exactly was going on, where they've now lived hundreds of, millions of years ago, that gives an appreciation, I think, for where we stand, not only on Earth, but, in the universe. And I think it's important to give that appreciation for, what the Earth is and the Earth's history on a local scale, because I think it's more relatable. And I think that, engaging with people on, local science, it's science studying your region is so important for, helping people care about science and for, helping people to have that appreciation and that interest and wonder in life and in, these pastimes.
That was beautiful. I would like that to be the end, but I've still got 2 questions left, and I'm not going to waste this paper. So, which questions are still left unanswered regarding the Appalachian dinosaurs?
I will have to see because I'm currently working on several new finds. Perhaps some new stuff. New dinosaurs from Appalachia. There are so many questions to be answered. And as we continue to find more things, the number of questions will just increase. And that's the wonderful thing, I think. There are questions ranging from, what were the smaller dinosaurs like on Appalachia? And can they tell us anything about small dinosaurs outside of Asia, where, primarily the record comes from? What was going on 65 million years ago? How did dinosaur faunas on Appalachia, change in the, millions of years leading up to the great, KT extinction? How, are these dinosaurs related to other dinosaurs from elsewhere in the Northern Hemisphere? As much as, we currently know about Appalachian dinosaur, evolution, as I said, the fragmentary fossil record means that we don't know a lot about, whether they form new groups or not. So we have a variety of new fossil finds. So, for example, recently I described a Tyrannosaur, partial Tyrannosaur foot from Delaware. It's the first Tyrannosaur from Delaware. And when you put it into a tree of Tyrannosaurs, what happens is that new, Delaware foot and, the 2 other known Appalachian Tyrannosaurs. These are 2 animals called Dryptosaurus, as I noted, and one from Alabama called Appalachiosaurus. And when you put them to get, into an analysis of Tyrannosaurs, they actually plot out as what's called a grade, where they're not forming a distinct family, but they're all sort of, closely related and, are closer together than they are to, stuff out west. So, there is evidence that we have new families out here. But, until we find more fossils and study them, that naming of new clades will have to wait. So that's a big unanswered question. Another one is, what were the dynamics of ecosystems out here? Specifically terrestrial ecosystems. What were they like? As I noted at the beginning of this, we don't really have a good record from sort of the middle of eastern North America, right where Illinois is, Iowa, places like that, and that's simply because there was no sediment depositing there during the Cretaceous. The Appalachian Mountains were too low for that. So what was going out there? What dinosaurs existed out there? That sort of questioning of the sparse record we do have, I think, will lead to some very interesting conclusions regarding northern hemisphere vertebrate evolution during the Cretaceous, and actually may tell us about the evolution of several important clades, like certain types of salamanders and frogs, certain types of mammals even, and as has recently been discussed, certain types of dinosaurs like the duckbills. So there are a variety of questions relating to the evolutionary biology of Appalachian vertebrates and their biogeography and ecology. And so the stuff I've done so far hopefully will just be a little sliver of the research and discovery that's yet to come from these sort of obscured deposits.
How well has all of this work been received by the academic community, given that you're still in high school?
Well, I try to keep my age and that sort of thing separate from the work. I try not to mention it as much as I can, simply because I believe that we shouldn't be focusing on that sort of thing. The research should be where the focus is, and so I'm very much for looking at scientific work objectively and trying to value the work for what it is, rather than judge it based on where the researcher is, where the researcher is coming from, any sort of thing like that. And so I try not to talk about it with people who I've worked with, and luckily enough, the paleontological community has been very sort of open to that. So it has worked out surprisingly well. And I'm just very glad that I'm able to can contribute to the scientific process and method in this wonderful growing field, and diversifying field too.
And I have to say that when I was doing the research for this interview, I got asked by one of our listeners to get something on the Appalachian Mountains, and all I did was just go onto Google Scholar, and your name came up, and I didn't know anything about you. I just saw the research and just thought, okay, this person sounds like the right person to get to interview, and I didn't make any assumptions as to your age or gender or ethnicity or anything like that. So I think it's some really good positive messages.
Yeah, well, I totally agree. I believe that we need to foster the dissemination of science among all groups, and that we need to focus on, making science as diverse as possible. Just simply because of the fact that, as someone who, maybe looked down upon because of, their age, luckily I haven't so far, but, there are so many cases where that has happened to certain people. And, I'm encouraged to see, the work of advocacy groups and at least the geological community and trying to diversify the community, and I look forward to that, because I believe that everybody is able to contribute something to the community that's very good, and I look forward to seeing the diversification of paleontology and the dissemination of scientific knowledge throughout humanity.
Well, I don't think there's anything left to say other than that, so thank you so much, Chase, for coming on the show.
Well, thank you very much. Have a good one.
Paleocast was brought to you by Dave Marshall, with Joe Keating, Laura Soul, Liz Martin-Silverstone and Caitlin Colery. It was made possible by funding from the Paleontological Society and the Paleontological Association, but the show now relies on contributions from you, the listeners. If you've liked this episode, please consider donating, and thanks to everyone that's helped out so far. We'd also like to thank the Ocean Collective for use of their music. Please visit paleocast.com for the supplementary material to this episode and for our archive of past programmes. Subscribe to our Twitter feed @Paleocast and like us at facebook.com/Paleocast to get all the latest news.